Welcome back, everyone, to another deep dive. This time, we're going to be taking a look at something that has the potential to be pretty revolutionary when it comes to creating images with AI, and that is VAR, or Visual AutoRegressive Modeling. It's sort of like, if you could imagine, like the much, much smarter cousin of those AI image generators that I'm sure you've all seen, but with some really serious upgrades. So we're talking things like 20 times faster speeds, shockingly good at like filling in missing parts of pictures, and this is the crazy part. It actually gets smarter the bigger it gets. So we've been poring over a ton of research notes and a really dense academic paper on this, and we're so excited to kind of break down the most exciting parts for you all today.
It's absolutely fascinating stuff, especially when you consider like the limitations of some of the earlier attempts at using autoregressive models for image generation.
Yeah. The paper we were looking at definitely didn't hold back. It almost felt like they were saying, like, here's why this whole approach was fundamentally flawed. So before we get into all the amazing things VAR can do, maybe we should like rewind a little bit. Can you help me understand why older autoregressive models just struggled so much with images?
Well, imagine you're trying to describe uh, a beautiful mosaic to someone who's never seen it.
Right.
You wouldn't just like list out every single tile in a line. I mean, you'd lose all the spatial relationships, the patterns, the beauty of the whole image. And well, that's kind of what those older models did to images. They treated them like a one-dimensional list of pixels, totally ignoring that inherent 2D structure that makes an image an image.
So they were like throwing away all this important information about how the pixels relate to each other.
Exactly. And that's a huge part of why they couldn't generate realistic and coherent images. They missed that essence of what makes an image work, visually. There were four main weaknesses they identified. The first was that they were violating this core mathematical assumption of those models, and they were struggling to perform something called zero-shot generalization. And then there was structural degradation in the images they generated. And honestly, they were just really inefficient.
Okay, so that's like the what went wrong part of the story. Now, how about we get into VAR and how it basically comes in and fixes all of these problems? Now, the paper kept using this term next scale prediction to describe VAR's approach. What does that even mean?
So next scale prediction means that VAR is actually seeing images more like we do. So instead of treating an image like a flat list of pixels, it understands it as like a hierarchy of details, starting with the overall composition and then progressively adding like finer and finer details, kind of like an artist adding layers of the paint to a canvas.
So like starting with a blurry outline and then gradually like sharpening the image until you have this fully detailed masterpiece.
Exactly. VA starts with a one-by-one pixel map, and then it just progressively adds details in these larger and larger blocks, always taking into account the info from those previous scales.
So when you say scales, what do you mean by that?
Well, think of it like zooming in and out of an image. Like at the largest scale, you see that overall composition, like the big picture. As you zoom in, you see more and more of those smaller details. And that's kind of how VR works. It builds up that image from coarse to fine, preserving those spatial relationships between pixels at each scale.
So like building a pyramid, you
Yeah.
start with this wide base and then add layers that get smaller and more detailed as you go up.
Exactly. And this like multi-scale approach, it's what makes VAR so efficient and scalable.
I see. It seems like VAR isn't just like fixing the problems of older models. It's exceeding expectations like across the board. I mean, the research even claims that VAR outperforms DIT, which is the tech behind those popular image generation tools like Stable Diffusion, right?
Yeah, and the researchers actually, they put them head to head, VAR and DIT. And the results were really pretty impressive.
Mm.
VAR consistently came out on top in 5 key areas: image quality and diversity, inference speed, data efficiency, scalability, and something called zero-shot generalization.
Whoa. Okay, we're definitely going to have to break all that down. But before we do, can we talk about that 20 times faster claim? What does that actually mean in practical terms? Like if I'm a graphic designer or someone who uses these tools, how would that impact my workflow?
Well, instead of waiting, hours or even days for an AI to generate a really high-quality image, you might be looking at minutes or even seconds. I mean, imagine the possibilities for things like graphic design, film, even video game development. You could iterate on design so much faster, experiment with different ideas more freely. You could be so much more productive.
That sounds like a total game changer. Okay, so VAR is fast, but is it actually producing like better images than DIT? What did they find when they compared the quality and diversity of the images generated by each model?
They found that even with fewer parameters than DIT, VAR was consistently creating images that were judged to be more realistic, more diverse, and just more visually appealing.
So it's not just faster, it's also producing better and more creative results. That's wild. What about this idea of data efficiency? Why is that important?
Well, training these AI models requires tons and tons of data, and that can be expensive and time-consuming to gather and process. But VAR, it's like it has this knack for learning really quickly from fewer examples. So it can achieve results comparable to data IT with significantly less training data.
Oh, wow. So it's not just faster and better, it's also more efficient in terms of how it learns. Okay, let's talk about scalability. You mentioned that VAR gets smarter the bigger it gets. Can you break that down a little bit and explain why that's so significant?
Okay, so as you increase the size of a VAR model, its performance actually improves in a really predictable way. Researchers are seeing what they're calling power law scaling laws in VAR.
Okay, I'm going to need you to break that down for me. What are power law scaling laws and why are they such a big deal?
Think of it like this. Power law scaling is like this superpower that lets researchers predict the future of their models. So as you increase VAR's size, its performance improves in a very specific, measurable way.
So it's not just a hunch that bigger is better, it's like a mathematical certainty.
Precisely. Researchers can actually estimate how much computing power they'll need to achieve a specific performance level, which is invaluable when you're dealing with these really massive AI models.
So it's not just about making better images today, it's about having this clear path to even more amazing advancements in the future.
Right. And that brings us to probably the most fascinating part of VAR. It's zero-shot generalization abilities.
Okay, this is the one that's really been blowing my mind. You're saying VAR can solve brand new problems without being specifically trained for them. It's like it can think outside the box. How is that even possible?
Well, the research paper gives some examples of VAR's zero-shot capabilities that are pretty remarkable. They call them image in-painting, image out-painting, and class-conditional image editing. And these really demonstrate VAR's surprising ability to handle tasks that it's like never even encountered before. It's not just about creating pretty pictures. It's about solving visual problems in a way that seems almost human.
Okay, let's take those one by one. What is image in painting and why is it so impressive?
Imagine you have an old photo that's been damaged, like maybe with a big scratch or a missing piece. VAR can intelligently fill in that gap based on the surrounding context, like a skilled art restorer would.
Wow, so it's not just copying and pasting pixels, it's actually understanding the content of the image and using that knowledge to recreate the missing parts.
Exactly.
That's amazing. Okay, what about image outpainting? What is that?
Think of your favorite painting. Have you ever wondered what's beyond the edges of the canvas? What if the artist had painted, a wider scene? Well, VAR can actually extend that image outwards, creating new scenery that perfectly matches the style and content of that original painting.
Okay, my mind is officially blown. And finally, what is this class conditional image editing thing? What does that even mean?
It means that VAR can add specific objects to a scene, like based on your instructions. So let's say you have a picture of a park and you want to add a dog running through the grass. You just tell VAR what you want and where to put it. And it'll just seamlessly integrate that dog into the picture, like taking into account the lighting, the perspective, the overall composition.
It really does sound like VAR is blurring the lines between art and technology.
Yeah.
And all of this is possible because VAR can, think visually in a way that previous models simply couldn't.
Yes. VAR's ability to understand and work with images at multiple scales, combined with its ability to learn and generalize from limited data is what makes all these amazing things possible.
This is all so fascinating, but I have to admit it's also a little bit overwhelming. I mean, if VAR can already do all this, what will it be capable of in 5 or 10 years?
That's the million-dollar question, isn't it? But the fact that researchers can already predict how much better a larger VAR model will perform is just so exciting. It really does suggest that we're on this trajectory of exponential progress in visual AI. And the possibilities are they're mind-boggling. But for now, how about we take a closer look at how this multi-scale approach actually works? It's like the secret sauce that makes VR so efficient and scalable.
Okay, yeah, I'm ready to get into the nitty-gritty. Help me understand how this multi-scale magic happens.
So before we got too caught up in all the incredible things VAR can do, we were talking about how its multi-scale approach is really key to its efficiency and scalability.
Yeah.
So let's kind of break down how that actually works in practice.
Okay, so you mentioned earlier that VAR generates those image blocks in parallel. What makes that so much more efficient than the way that older models work?
Okay, so imagine you're building a house. Traditional models, it's like constructing it brick by brick. laying each one sequentially, one after the other. VAR, on the other hand, is like having multiple teams working simultaneously
Huh.
at different sections of that house.
So instead of waiting for one task to finish before starting the next one, VAR can, like, multitask like a pro.
Exactly. And this parallel processing it massively reduces the time it takes to build that entire image.
Okay, that makes sense. The research paper also mentions something about reduced computational complexity. Is that related to this parallel processing?
It's another key advantage, yeah. So those older models, they require a ton of computing power because they're predicting each individual pixel in sequence.
Right.
But VAR's multi-scale approach actually reduces the number of calculations needed, making it way more computationally efficient.
So it's not only faster, it's also using less computing power to get the same results. That seems like a big win for anyone working with these models, especially if they don't have access to, like, these massive server farms.
Oh, absolutely. And the efficiency just keeps getting better as you scale up the model. So larger VAR models can actually achieve the same level of performance as smaller models, but with significantly less computation.
It's like getting more bang for your buck in terms of computing resources. That ties into VAR's scalability, this idea that it gets better the bigger it gets. It sounds almost too good to be true. Is there a catch?
Well, the catch is that you need more computing power to run those larger models. But the amazing thing is that this scaling, it follows a predictable pattern. Researchers are finding what they call power law scaling laws with VAR.
Okay, can you remind me what those are and why they're so important?
Okay, so think of it this way. Power law scaling is like having this superpower that lets researchers actually predict the future of their models. What it means is that as you increase VAR size, its performance improves in this very specific, measurable way.
So it's not just like a hunch that bigger models are better, it's like a mathematical certainty.
Exactly. Researchers can estimate pretty accurately how much computing power they'll need to achieve a specific performance level, which is so valuable when you're dealing with these really massive AI models. It takes a lot of the guesswork out of that whole development process.
This is sounding more and more like VAR is like the chat GPT of image generation. They're both built on this idea of, like, scalable architecture that lets them learn and improve at an incredible pace.
Yeah, I like that comparison. Both of them are pushing those boundaries of what AI can do.
Yeah.
And just like ChatGPT revolutionized how we interact with language,
Yeah.
VAR has the potential to just totally change how we create and work with images.
And all of this just stems from VAR's ability to learn and generalize so effectively, right?
Yeah. Yes. It's that multi-scale approach combined with the power of those transformers that allows VAR to learn these really complex patterns and relationships within images and this deep understanding of visual information. That's what allows for those zero-shot generalization capabilities we talked about. It's not just about memorizing images. It's about learning those underlying principles of visual composition and structure.
So it's almost like VAR is developing a sort of visual intuition. Like, it can actually see and understand the world in a way that's starting to look a lot like human perception.
That's a great way to put it. And that raises some really interesting questions about the future of art and creativity in general. I mean, if AI can generate images that are indistinguishable from those made by humans and even extend them or manipulate them in these really creative ways, what does that actually mean for human artists and designers?
That's definitely a question we're going to have to explore further, but I think it's important to remember that we're still in the very early stages of VAR's development.
Yeah.
It's super exciting to think about all the possibilities, but we also need to be realistic about the potential challenges.
Oh, absolutely. Like any powerful new technology, VAR needs to be developed and used responsibly. We need to be aware of any potential biases that could be embedded in the data that's used to train these models. And we need to be thoughtful about how we use these tools in a way that benefits, society as a whole.
Yeah, I'm glad you brought up that point about bias. It seems like every time there's a big jump forward in AI, there needs to be a conversation about ethics and responsibility. It's this reminder that technology is never really neutral. It reflects the values and priorities of its creators.
That's a crucial point. As we continue to develop these really powerful AI systems, we have to be mindful of the potential consequences, both good and bad. We need to be asking ourselves, not just what can we do, but what should we do?
It's like we're standing at this crossroads where we have this incredible opportunity to use AI to solve some of the world's biggest problems. But we also need to be careful not to create new problems in the process.
That's a great way to put it. Yeah, it's a balancing act, and it's one that we all need to be a part of.
This is kind of reminding me of that Spider-Man quote, "With great power comes great responsibility." Seems especially relevant in the age of AI.
Totally agree. We really do have a responsibility to use these tools wisely, ethically, and to make sure they're used to help create a more just and equitable world for everyone.
Well, I think we've covered a lot of ground today, from the technical details of VAR's multi-scale approach to the broader ethical implications of, like, its capabilities. It's been a pretty amazing journey.
It really has. And it's a journey that's just getting started.
We've really only just scratched the surface of what VAR can do and what it could mean for, like, the future.
Yeah, before we get too lost in speculation about the future, let's just take a minute to appreciate the ingenuity and creativity that have gotten us to this point. VAR is really a testament to the power of human innovation, and it's a reminder that we're constantly pushing the boundaries of what's possible.
I love that perspective. It's easy to get caught up in all the hype and fear around AI, but ultimately it's a tool
Mhm.
and we can choose to use it for good or for bad. It's up to us to decide what kind of future we want to build with it.
Well said. And I have a feeling that the future of VAR and AI in general is going to be full of surprises. We're really just at the beginning of this incredible journey of discovery. And I, for one, can't wait to see what we learn and create along the way. I neither. And on that note, I think we're going to take a quick break and be back in a moment to wrap up this deep dive into the world of VAR. We'll leave you with some final thoughts and some resources so you can keep exploring this amazing frontier of AI innovation. Stay tuned. All right, we are back, ready to wrap up our deep dive into the world of VAR. We've gone over a lot, from the technical details to the mind-blowing potential of it all, and even, the ethical considerations that inevitably come along with any powerful new technology.
It really has been quite a journey. And like you said, we've really only just scratched the surface of what VAR can do, what it might mean for the future, all of that.
Exactly. And that's exactly why we want to encourage everyone listening to actually go and explore VAR for themselves. We're going to make sure to include links to the online demo and the code repository in the show notes, because seeing it in action it's really something else. You can play around with some of those zero-shot capabilities we talked about,
Hmm.
like the image and painting and outpainting. It's pretty cool. Oh, yeah. It's one thing to hear us describe it, but to actually experience it firsthand, it's a whole other level. Plus, this technology is moving so fast. What we've talked about today might just be like a tiny glimpse of what's to come.
Right. It's like we're witnessing the birth of a whole new art form, one where those lines between human creativity and artificial intelligence they're kind of starting to blur. Who knows what incredible applications we'll see in the coming years.
We might even see it, integrated into everyday tools and devices,
Hmm.
changing how we create images and interact with them in our daily lives. Imagine if anyone could generate photorealistic images, edit photos with ease, or even create entire virtual worlds, all powered by AI.
Yeah, it's exciting and a little bit daunting to think about all the possibilities, isn't it? But like we've been saying, this power comes with responsibility.
Absolutely.
Hmm.
We need to be thinking about the potential impact, how these technologies might affect society, and making sure that they're used to create uh, a more equitable and just world.
Well, this deep dive has definitely been a whirlwind of insights. We've explored a lot of the technical marvels of VAR, but it's clear that this goes way beyond just computer science. It's really a reminder that we're living in this time of like crazy technological change, and we all have a part to play in shaping the future.
I completely agree, and I think it's a future that's full of possibilities. If VAR can already do all this, just imagine what we'll be able to create, together in the years ahead.
Well, thank you everyone so much for joining us on this exploration of VAR. We hope you enjoyed the deep dive and that you'll continue to explore and learn and stay curious about the world around you.
Yes, until next time, keep asking questions, keep challenging those assumptions, and keep diving deep into this fascinating world of knowledge,